Given a spherical point, 2, negative pi fourths, and pi halves, find the rectangular coordinates. So what we're going to do here is we're just going to use those equations that we had for spherical coordinates to do the points. So that would be these ones. And we have rho, theta, and phi here. Oops, I'm trying to draw a decent phi. Okay, there's a decent one. Okay, so we're going to have to plug in those values for that. So then for x, we're trying to find x. So my rho is 2. My sine of theta is going to be sine of negative pi fourths. And it's going to be times, oops, it says sine phi. So I mixed that up. So my phi is pi halves. And my theta is negative pi fourths. Okay, there we go. So that's going to be my x value. So what we get here, 2, sine of pi halves is 1, and cosine of negative pi fourths is going to be root 2 over 2, or 1 over root 2. And this is going to simplify here. So this actually just gives me root 2. Now for my y, I have 2 for my rho. Now I'm looking right here. Okay, so for my sine of phi, that's going to be sine of pi over 2. And then cosine, oops, I looked at the wrong one. Then sine of theta is going to be negative pi fourths. So this is going to equal 2, and sine of pi halves is 1, times sine of negative pi fourths is negative root 2 over 2. So those 2's cancel just like the other one. And I get negative root 2. Okay, now for the last one, my z. Z equals rho, which is 2, cosine, and phi, which is pi halves. Now pi halves, cosine of pi halves is 0, so 2 times 0 is 0. So now we have our coordinates here. So our coordinates are going to be, for x we had root 2, for y we have negative root 2, and for z we had 0. So there is our rectangular coordinates, and from the spherical point. So now let's take a look at the next one here. It says, given the equation of a surface in rectangular coordinates, x squared plus y squared equals 9, find the equation in spherical coordinates. So what we're going to do here is we're just going to use those same equations above and plug in wherever we can. So with this one, I need to turn this into spherical coordinates. So I'm going to take this one here. I have x squared plus y squared equals 9. And I'm also going to take this equation here. And the reason why is because it has an x squared plus y squared in it. So that's going to be a rho squared equals x squared plus y squared plus z squared. Now if I take this equation here, well actually I can just take this x squared plus y squared and actually just put the 9 in place of it here. So what that means is I end up with, I should say this and this implies rho squared equals 9 plus z squared. So then what I get from this is rho squared minus z squared equals 9. Well, let me fix my 9. And then what I can do further from here is I know z equals rho cos phi. So I'm just going to put that in here because I have to get it in terms of rho, phi, and thetas. Okay, so now plugging that in there, I'm going to get rho squared minus, and then this is going to be rho cosine phi, and then squared equals 9. So then that's going to give me a rho squared minus rho squared cos squared phi, and that equals 9. Now, if I pull a rho squared out of both of these here, I'm going to get a rho squared, and this is going to be a 1 minus cosine squared phi, that equals 9. And 1 minus cosine squared phi is actually sine squared phi. So this is going to be rho squared sine squared phi equals 9. Now what I'm going to do is square root both sides. So then this is going to be a rho now, sine phi, and it's going to equal plus or minus 3. So now I want to get functions in terms of rho equaling sine and phi, or phi and theta when I can. So I'm going to divide by the sine of theta. So this is going to be rho equals plus or minus 3 over sine of phi. And this simplifies a little more because 1 over sine of phi is going to be cosecant of phi. So this rho then is going to equal plus or minus 3 cosecant phi. Hope I said cosecant phi. Okay, so that is going to be our final answer for this one. So there's quite a bit of maneuvering around there to get to that answer. I don't know if there's an easier way to do it, but this one actually works. So there it is.